All right, we're in the Pilot's Handbook of Aeronautical Knowledge, Chapter 3, page 3, Effects of Humidity on Density. The preceding paragraphs refer to air that is perfectly dry. In reality, it is never completely dry. The small amount of water vapor suspended in the atmosphere may be almost negligible under certain conditions, but in other conditions, humidity may become an important factor in the performance of an aircraft. Water vapor is lighter than air. Consequently, moist air is lighter than dry air. Therefore, as the water content of the air increases, the air becomes less dense, increasing density, altitude, and decreasing performance. It is lightest or least dense when, in a given set of conditions, it contains the maximum amount of water vapor. Humidity, also called relative humidity, refers to the amount of water vapor contained in the atmosphere and is expressed as the percentage of the maximum amount of water vapor the air can hold. This amount varies with temperature. Warm air holds more water vapor, while colder air holds less. Perfectly dry air that contains no water vapor has relatively humidity of 0%, while saturated air, which cannot hold any more water vapor, has a relative humidity of 100%. Humidity alone is usually not considered an important factor in calculating density, altitude, and aircraft performance, but it does contribute. As temperature increases, the air can hold greater amounts of water vapor. When comparing two separate air masses, the first warm and moist, both qualities tended to lighten the air. The first must be less dense than the second. Pressure, temperature, and humidity have a great influence on aircraft performance because of their effect upon density. There are no rules of thumb that can easily be conveyed, but the effect of humidity can be determined using online formulas. In the first case, the pressure is needed at the altitude for which density altitude is being sought. Using figure 3-2, select the barometric pressure closest to the associated altitude. An example, the pressure at 8,000 feet is 22.22. Yes. Using the National Oceanic and Atmospheric Administration website, enter the 22.22 for 8,000 feet in the station pressure window. Enter in the temperature of 80 degrees and a dew point of 75 degrees. The result is a density altitude of 11,564. With no humidity, the density altitude would be almost 500 feet lower. Another site is provides more straightforward method of determining the effects of humidity on density altitude without using additional interpretive charts. In any case, the effects of humidity on density altitude include a decrease in overall performance in high humidity conditions. So the other site is wahaddin.net/calc/density_altitude. So we'll hold off right there. That was on 3-4. We just finished with density altitude, effects of humidity on density. See ya.